This lesson looks at a power or a polynomial with a degree higher than 3 or higher than a cubic function. So what we're going to do is look at a polynomial with degree 4. That's called a quartic. They take this general form here, but they can also be of this form here. And this is very similar to parabolic turning point form or cubic inflection form. So let's have a look at the basic quartic, and it looks very much like a parabola, and that shouldn't surprise you because if you consider the function y equals x to the 4, it's very similar to the function y equals x squared. So what happens is when you power 4 a negative number, it becomes a positive number. When you power 2 a negative number, it becomes a positive number. Okay, and the same behavior occurs on the other side. So if I sub into this one here, x equals -2, say, and x is equal to 2, it'll yield the same result. So they're symmetric. The only real difference, I mean, they jump very, very quickly, quartics, because instead of power 2ing something, you're power 4ing it, okay? But the other thing is it has this sort of flatter bottom here. And to understand that, you've got to think of maybe what might happen if I sub in a half into both of these functions. So if I stick a half into the x squared function, I'm going to get y equals a quarter. If I sub a half into that, I'm going to get a 16th. So it's a half of a half of a half of a half. Okay, so that's going to be 1/16. And so what you need to know is that these small values here get smaller and smaller and smaller and smaller. And so they usually result in these really sort of flatter or much flatter spots there. Okay. There's heaps and heaps and heaps of different varieties of quartics, but the important thing to note is that quartics behave like parabolas, and that is a positive quartic will always start like a parabola, okay, like a positive parabola. That is, it'll start with like a negative gradient, 0 gradient, and then a positive gradient. So all quartics that are positive will start like this. Now remember, the difference is with cubic functions, all positive cubics start with a positive gradient, okay? So it's very important to note that all quartics will start with this negative gradient or will be like parabolic in nature. So let's do a quartic with no x-intercepts. So that's like this general form, but translated 4 units up, say. So that would be x to the 4. So like that's a positive. We could have one x-intercept. There's an example. So that would be like a negative x to the 4. Okay, and one x-int. This one is no x-int. What else can we get? We can get one x-intercept like this. So we can get a stationary point of inflection. Actually, this is going to be 2 x-intercepts. So this is an example of 2 x-intercepts. Now that is going to be a negative x to the 4 function, and that is 2 x-int. Here's another 2 x-intercept quartic. So that's a positive x to the 4, and that's a 2 x-int. Got heaps of different ones we can draw here. What else can we get? We can get a 3 x-intercept. So there, there, and there. So that one there is a negative quartic, 3 x-int. We can get the positive version of that quite easily. So it would look something like this. What else can we get? We can get a 2, how else can we get a 2 x-intercept? Just trying to think of another way we can get it. Inflection, like that. So there's an x to the 4, 2 x-int. How can we get a 4 x-intercept? like that. So 1, 2, 3, 4. So that's a positive x to the 4, 4x int. We can get a negative version of that. That's the same one. What am I doing? So I can get that. So that's x to the 4 negative, and that is 4x int. And one last one. What am I going to draw for this one here? Heaps of different varieties. Let's just go back to a 1 x-intercept positive. So this is an x to the 4, 1x int. All right, so there's some examples of different quartics that can arise. All right, so let's have a look at some. So we want to sketch this graph labeling the x-intercepts and turning point with coordinates. So what this is a basic quartic. The y equals x to the 4. It's been moved 2 units to the left and 5 units down. Okay, now before I send this down 5 units, I'm just going to get the y-intercept, which occurs when x is equal to 0. So that's going to be 2 to the 4, which is 16. So that's about 11. So 5, 10. So somewhere up here will be 11. So here I'm going to place -5, and that's going to be my turning point. All right, so what the quartic is going to do, it's going to sweep down like this and come up through the 11. So I'm going to try and draw it on this side. Remembering the quartics sort of have got that flat bottom. And they are also symmetric about the axis of symmetry. All right, so there's my quartic. Now, again, can you please make sure you clean up, like don't leave something like that in your notes. What else do we need to include? Label the x-intercepts with turning points with coordinates. So the turning point is -2, -5. Here is the y-intercept. And let's get the x-intercepts. There's 2 of them. So we're going to go 0 equals x plus 2 to the 4. Take 5. Now add 5 to both sides. Now what we're going to do is fourth root both sides. And because it's a positive, it's an even root, what will happen is that it will generate 2 solutions. It could be the negative or it could be the positive. So we're going to say that x plus 2 equals plus or minus the fourth root of 5. Therefore, x is plus or minus the fourth root of 5, take 2. Right, so which one's which? Well, -√5 take 2 will be this one. So we can label that -√5 take 2, 0. And this one here will be the larger of the 2, which is, I forgot the fourth root there. It is the fourth root of 5 take 2, 0. That's that one there. All right, so there's a quartic in turning point form. All right, let's have a look at some others. All right, so we want to solve these 2 problems here. So we've got x to the 4 take 27x, remembering that we want to get the left-hand side equal to 0 or the right-hand side equal to 0. Some of you guys will divide by x on both sides, which is a really bad assumption in this case because that assumes that x can't be 0, in which case let's see what's about to happen. X comma x cubed take 27 equals 0. So now we're going to solve this via the null factor law, which says that x could be 0 and x cubed could be 27, in which case x could be 3. So over here, if we actually divided by x and divided by x, this assumes that we can do this because x can't be 0, which again, have a look at this. This is a bad assumption, and that's why you just don't want to use that method of solving. Now, what would this look like? It doesn't say to sketch it, but I'm going to try to consider what it's going to look like. I've got an x-intercept at 0 and an x-intercept at 3, okay? Now, this 2x-intercept 1, I'm predicting is going to, what is it? It's a positive, so it's going to, I think, just be something like that. All right, let's have a look. All right, I've just swung in GeoGebra, and we're going to graph f of x equals x to the 4, take 27x. Oops. I just had a quick look to the right and thought, what graph is that? So 27x. All right, so we've got our standard upright quartic there, okay, with turning point way down there somewhere. Okay, so there's its behavior. So what it does, and its point of difference with the parabola, is it sort of swings in on much more of an angle, and it's not symmetric. Okay, so this one here is not symmetric. All right, let's have a look at the next question. Okay, so what we want to do is solve this. So we want to get it into factored form, and note that what we're going to do is pull out a factor to begin with. So we're going to grab x squared take 2, x take 24 equals 0. Now what we're going to do is x 6, 4 negative, x squared, x take 6, x plus 4 equals 0. That's x is equal to 0 for that one, x is equal to 6, x equal to negative 4. Let's have a think about what this one might look like. All right, now notice that this one here has got a squared next to it, which means we've got the repeated factor. That means we're going to get a bounce at that point here, okay? So what we're going to do is mark in 0. Here is negative 4, here is 6. And it's a positive quartic, so it's going to start with a negative gradient. So what's going to happen is it's going to come through the negative 4, come back up again, bounce, and it has to turn somewhere else, and it's going to come through there. So it's going to look something like that. Don't know how low to draw those turning points there. That's just a bit of a guess. Let's have a look at it in GeoGebra. Okay, so g of x equals x to the 4, take 2x to the 3, take 24x squared. Oh my goodness, this is a new version of GeoGebra. So I'm sorry I'm so clumsy with it. X to the 4, take 22x to the 3, take 24x squared. All right, let's have a look. Yeah, so sure enough, it is a bit of a lopsided one, and I mean, look how low the turning point is there at negative 260. Okay, so but yeah, we got the general shape of it quite good in our notes there, albeit lucky I didn't commit to any y values there because it's way low. Right, so there's an interesting one. Now this one here, you might think, or some students think, that this coordinate here, or this x-intercept, will be an inflection because it's a power 3, but in fact it's not for that one. It's just a standard cut through the x-axis. Where it would be an inflected graph, like I'd imagine something like, imagine you had this x bracket x take 3 all cubed. So if you were to solve this, 0 equals x take 3 all cubed, it's going to be x is equal to 0 and x is equal to 3. Now in this case, what would happen is this would be the unusual factor, so it's going to go through 0 and 3, and what's going to happen is that it's a positive quartic, so it's going to cut through there, come back up through here, and something special is going to happen here, and because it's cubed, it's going to have that inflection point there, rather than, say, the squared one earlier, which has the bounce. So that's what a cubed factor will do on a graph, is it's going to inflect. All right, are there any more questions? No. All right, so that's the video for today. Go ahead and knock over 6i.